कल्पना कीजिए किसी पेशेंट का टेस्ट पॉजिटिव आता है, तो क्या वह सचमुच बीमार होगा? कोर्ट में नया एविडेंस आता है, तो क्या किसी के अपराध की प्रोबेबिलिटी बदल जाएगी? कोई ईमेल सस्पिशियस दिखती है, तो क्या वह सच में स्पैम होगी? किसी स्टॉक का मार्केट रिपोर्ट आता है, तो क्या उसका प्राइस राइज या फेल होने की प्रोबेबिलिटी बदल जाएगी? किसी वेबसाइट पर नया ऐड दिखाई देता है, तो क्या यूजर उसे क्लिक करेगा? किसी वेदर फोरकास्ट में बारिश की प्रोबेबिलिटी नए सैटेलाइट डेटा आने पर कैसे अपडेट हो? इन सभी सिचुएशंस में प्रोबेबिलिटी का सही मैथमेटिकल तरीका है बेस थ्योरम। बेस थ्योरम का नाम रेवरेंड थॉमस बेज के नाम पर रखा गया है, जो 18th सेंचुरी के एक इंग्लिश मैथमेटिशियन, और उन्होंने ही ये थ्योरम दिया। तो आइए जरा समझते हैं कि बेस थ्योरम क्या है। सपोज a1 a2 डॉट डॉट an are n mutually exclusive and exhaustive events, and b is an observed event. Then the conditional probability of ai when b is given. What is ai here? Ai is any one of these n events. ठीक है, so if b is given, then to find the conditional probability of ai when b is given by this formula. This is probability of ai multiplied by the conditional probability of b when ai is given divided by the total probability of b. Total probability of b is given here. Probability of a1 multiplied by probability of b when a1 is given plus probability of a2 multiplied by probability of b when a2 is given plus dot dot plus probability of an multiplied by probability of b when an is given. So this is the summation of the product of the probability ai and the conditional probability of b when ai is given. This is the total probability of b. So this is the formula to find the conditional probability of ai when b is given, and this is called Bayes theorem. ठीक है? If we talk about the real applications of Bayes theorem, then Bayes theorem is being used in many of the areas like medical diagnosis, spam email filtering, machine learning, legal analysis, forensic analysis, quality control, fault detection, search engines, recommendation systems, and many more. So let us see one related example. ठीक है, ये एग्जाम्पल है, a certain disease affects 1% of the population. A medical test for this disease has the following characteristics. First is, if a person has the disease, the test is positive 99% of the time. If a person does not have the disease, the test is positive 5% of the time. ठीक, then if a person tests positive, what is the probability that they actually have the disease? चलिए इस क्वेश्चन को हम लोग सॉल्व करके देखते हैं। क्वेश्चन का कहना है, ए सर्टेन डिजीज अफेक्ट्स 1% ऑफ द पॉपुलेशन, मीन्स द प्रोबेबिलिटी ऑफ डिजीज in the population is 1%. This is equal to 0.01. इसका मतलब probability of no disease in the population is equal to 1 minus probability of there is disease. This is equal to 1 minus 0.01. This is equal to 0.99. This is the probability that the population will have no disease. Now, the characteristics are, if a person has the disease, the test is positive 99% of the time. It says the conditional probability of test positive when there is disease, this is equal to 99%. This is 99%, means 0.99. And the second one is, if a person does not have the disease, the test is positive 5% of the time. Means the probability of the test positive when there is no disease is equal to 5%. Means this is equal to 0.05. तब हमें निकालना क्या है? If a person tests positive, what is the probability that they actually have the disease? मतलब ये कि अगर पता चल गया, if a person test positive, किसी पर्सन का टेस्ट पॉजिटिव आता है, तो उसको डिजीज होने का क्या चांस है? मीन्स वी हैव टू फाइंड द प्रोबेबिलिटी ऑफ डिजीज व्हेन द टेस्ट इज पॉजिटिव. This is we have to find. And here we have to take the help of Bayes theorem. Bayes theorem का help कैसे लेंगे? So देखिए. So by Bayes theorem we have probability of D when the test is positive is equal to probability of the test positive when there is disease multiplied by probability of disease divided by the total probability of the test positive. Means probability of test positive when there is disease multiplied by probability of disease plus probability of the test positive when there is no disease multiplied by probability of no disease. And this is equal to probability of conditional probability of test positive when there is disease. It has been given here 99%, means 0.99. So this is equal to 0.99 multiplied by probability of disease is 0.01. 0.01 divided by 0.99 multiplied by 0.01 plus probability of the test positive when there is no disease is given here 0.05. 0.05 multiplied by probability of no disease, it is 99%, 0.99. 0.99. This is equal to, we can multiply the numerator and denominator by 10,000, 1 followed by 40 to remove the decimal symbol. This is 99 divided by 99 plus 99 into 1 is 99 plus 5 into 99. This is equal to 99 divided by, you are taking 99 as common. We have 1 plus 5. This is equal to 99 divided by 99 into 6. And 99 cancel. This is equal to 1 by 6. And this is the required probability. Okay? Okay. The next question is, two computers A and B are to be marketed. A salesman who is assigned the job of finding customers for them has 6%, 60%, and 40% chances respectively of succeeding in case of computer A and B. The two computers can be sold independently. Given that he was able to sell at least one computer, what is the probability that computer A has been sold? Means we have been given here the probability of the computer A will be sold is 60%. This is equal to 0.60. And the probability that the computer B will be sold is equal to 40%, means 0.04. ठीक है? The two computers can be sold independently, means probability of A intersection B will be equal to probability of A multiplied by probability of B, because the events are independent. Take, given that he was able to sell at least one computer, what is the probability that computer A will be sold? ठीक है, means we have to find the probability of A when A union B is given. So for this, first of all, we have to find the probability of A union B. How can we find it? It can be found by probability of A plus probability of B minus probability of A intersection B. This is equal to, this is 0.60 plus 0.40 minus 0.60 multiplied by 0.40. ठीक है, this is equal to, this is 1 minus 6 4 24, 0.24. This is equal to 0.76. Okay, we can find this probability in this way also. इसी probability को हम इस तरह से भी निकाल सकते हैं. Probability of A union B is equal to 1 minus probability of A union B not A union B. Means we can find it 1 minus probability of not A intersection not B. This is equal to 1 minus probability of not A multiplied by probability of not B. This is equal to 1 minus probability of not A. Probability of A is 0.60. So probability of not A is 1 minus 0.60 multiplied by 1 minus 0.40. This is equal to 1 minus 0.4 multiplied by 0.6. This is equal to 1 minus 0.24. This is equal to 0.76. So in this way, we can find the probability of A union B. Now, conditional probability of A when A union B is given is equal to probability of A intersection A union B divided by probability of A union B. This is by formula probability of A when B is given is equal to probability of A intersection B divided by probability of B, the product rule. So this is equal to, now here A intersection A union B is equal to A. So this is equal to probability of A divided by probability of A union B. This is equal to probability of A 0.60 divided by probability of A union B is 0.76. The next question is, suppose that a product is produced in three factories X, Y, and Z. It is known that factory X produced thrice as many as times as factory Y, and that factory Y and Z produce the same number of items. Assume that it is known that 3% of the items produced by each factories X and Z are defective, while 5% of those manufactured by factory Y are defective. All the items produced in the three factories are stocked and an item of product is selected at random. What is the probability that this item is defective? Or the second, if an item selected at random is found to be defective, what is the probability that it was produced by factory X, Y, and Z respectively? This is very long question, but we can understand properly. See, the question is, suppose that product is produced in three factories X, Y, and Z. We have three factories. ठीक है? And it is known that factory X produced thrice as many as times as factory Y, and that factory Y and Z produce the same. It means the proportion of the products being produced in these three companies X, Y, Z is equal to 3:1:1. X produces thrice as many as Y produces, and Y and Z produce the same. So this is the proportion. It means the probability of the products to be produced from company A, company X, is equal to 3 divided by 3 plus 1 plus 1, 5. And probability of Y is equal to 1 divided by 5. And probability of Z equal to 1 divided by 5. ठीक है? Next statement is, assume that it is known that 3% of the items produced by each factory X and Z means the conditional probability of the defective item when it is produced from X is equal to 3%. Means this is equal to 0.03. And the same probability is for company Z. Probability of D when it is produced from Z, X and Z both are equal. This is equal to 0.03. And probability means conditional probability of defective item when it is produced from Y is equal to 5%. This is 5%. This is equal to 0.05. ठीक है। नेक्स्ट इज all the items produced in the three factories are stocked and an item of the product is selected at random. ठीक है। What is the probability that this item is defective? So we have to find the total probability of defective item. How can we find the total probability? Means probability when the product is from company X plus probability when the product is from company Y plus probability when the product is from company Z. So the total probability is equal to probability of company X multiplied by probability of defective item when it is from X. This plus probability of Y multiplied by probability of D when it is from Y plus probability of Z multiplied by probability of defective item when it is from Z. This is equal to probability of X is 3 by 5. So it is 3 by 5 multiplied by probability of D when X is given. This is equal to 0.03. 0.03. Again, probability of Y is 1 by 5. So 1 by 5 multiplied by probability of D when it is from Y, 0.05. Plus probability of Z, it is also 1 by 5. So 1 by 5 multiplied by probability of D when Z is given. So D when Z is given is here 0.03. 0.03. This is equal to 3 3 ja 9, 0.09 divided by 5 plus 0.01. 5 cancel. 0.01 plus 0.03 divided by 5. Okay, this is equal to, taking 5 as LCM, we have 9, 0.09, 0.05 and 0.03. 9, 5, 14, 3, 17. 9, 5, 14 plus 3, 17. 0.17. And removing the decimal sign, it is 17 divided by 500. ठीक है? This is the total probability of the defective item. Now, the question is, if an item selected at random is found to be defective, what is the probability that it was produced by factory X, Y, and Z respectively? Means we have to find the conditional probability of X, Y, Z when the product is found to be defective. Means we have to find the probability of X when D is given, also probability of Y when D is given, also probability, conditional probability of Z when D is given. ठीक है? We can find all these probabilities using Bayes theorem one by one. So conditional probability of X when defective item is found. This is equal to probability of X multiplied by probability of defective item when X is given divided by the total probability of D is equal to probability of X. Probability of X is 3 by 5. So this is 3 by 5 multiplied by probability of D when X is given. D when X is given is 0.03. 0.03 whole divided by PD, total probability 17 by 500. Okay, this is equal to, this is equal to 3 3 is 9, 0.09 divided by 5 into 17 multiplied by 500. This is equal to, चलिए इसको हम यहां लिखते हैं अब। दिस इज इक्वल टू कितना, 9, 0.09 multiplied by 500 is 9 5 जा 45. This is equal to 45 divided by 17 5 जा 85, which is equal to 9 divided by 17. हम इसको यहां पर भी कैंसिल कर सकते थे, 5 से इसको कैंसिल कर सकते, 9 by 17, and this is the correct answer. This is the probability of, this is the conditional probability of the factory X when the product is found to be defective. Similarly, we can find the probability of Y when it is defective and the conditional probability of Z when it is defective. इस तरह से हम फाइंड कर सकते हैं अलग अलग, ठीक है। Now, the next question is, a factory produces a certain type of outputs by 3 types of machine. ठीक है, the respective daily production figures are machine 1 3000, machine 2 2500, machine 3 4500. Past experience shows that 1% of the output produced by machine 1 is defective. The corresponding fractions of defective for the other two machines are 1.2% and 2% respectively. An item is drawn at random from the day's production run and is found to be defective. What is the probability that it comes from the output of machine M1? It comes from the output of machine M2. It comes from the output of machine M3. Now, let us first count the total number of products produced by the 3 machines. Total number of products is equal to 3000 plus 2500 plus 4500. This is equal to how much? 4500 plus 2500 is 1700, and 7000 plus 3000 is 10,000. Now, the probability of machine M1 means the probability of the production from machine M1 is equal to 3000 divided by 10,000 is equal to 3 by 10 is equal to 0.3, and probability of machine M2 means the probability of the production from machine M2 is production from machine M1 M2 is 2500 by the total 10,000 is equal to 2020 cancel, 25 for 100. So this is 1 by 4 or this is equal to 0.25. Again, probability of the production from machine M3 is equal to, this is 4500 divided by 10,000. This is equal to 0.45 or 9 by 20. 9 5 जा 45, 25 जा 100, 9 by 20. Okay. Now, past experience shows that 1% of the output produced by machine M1 is defective. So if the production is from machine M1, the defective conditional probability of the defective item when it is produced from M1 is equal to how much percent? This is 1%. 1%. This is equal to 0.01. Probability of defective item when it is produced from M2 is equal to, this is 1.2%. 1.2% means this is equal to 0.012, and probability of defective item where it is produced from M3 is equal to 2%, means 0.02. Okay. An item is drawn at random from the day's production run and is found to be defective. What is the probability that? Means defective here is an observed event. So we have to find the conditional probability of machine M1 when it is defective, then the conditional probability of machine M2 when it is defective, then the conditional probability of machine M3 when it is defective. सो इन तीनों क्वेश्चंस को सॉल्व करने के लिए सबसे पहले हम टोटल प्रोबेबिलिटी फाइंड कर लेते हैं. सो टोटल प्रोबेबिलिटी ऑफ डिफेक्टिव आइटम, डिफेक्टिव आइटम्स मीन्स प्रोबेबिलिटी ऑफ डी is equal to, this is equal to probability of M1 multiplied by probability of D when M1 is given plus probability of M2 multiplied by probability of D when M2 is given plus probability of M3 multiplied by probability of D when M3 is given is equal to probability of M1 is 0.3 multiplied by probability of D when M1 is given is this 0.01 plus probability of M2 is this 0.25 multiplied by probability of D when M2 is given, this is 0.012 plus probability of M3 is 0.45 multiplied by probability of D when M3 is given is 0.02. This is equal to 0.3 multiplied by this 0.01 is 0.003 plus this is equal to 0.003, 0.003, 0.009, and this is equal to 3369, 15, 0.0159312 plus 315. This is the total probability. It can be converted in the fraction like this 15 by 1000 और 3 डिवाइडेड बाई 200. हम लोग इसका जैसे यूज करना होगा कर लेंगे. नाउ द फर्स्ट क्वेश्चन इज कंडीशनल प्रोबेबिलिटी ऑफ मशीन M1. So conditional probability of machine M1 when it is found to be defective is equal to 0.003 divided by 0.015. This was the total probability, and this is equal to 1 by 5. Similarly, second point, conditional probability of M2 when D is given is equal to probability of M2 multiplied by conditional probability of D when M2 is given divided by the total probability of D is equal to. This is equal to the second probability was 0.03 again, है ना? The 0.003 divided by 0.015. This is equal to 1 by 5. And third point is conditional probability of M3 when D is given is equal to probability of M3 multiplied by conditional probability of D when M3 is given divided by the total probability of D. This is equal to 0.009. This was the probability in the third case divided by the total probability 0.015, and removing the decimal and then cancelling, we can find this is equal to 3 by 5. This is the required probability. Okay. Now, the next question is, in 2019, there will be 3 candidates for the position of assistant professor, Mr. Chatterjee, Mr. Iyengar, and Dr. Singh, whose chance of getting the appointment are in the proportion 4:2:3 respectively. The probability that Mr. Chatterjee, if selected, would introduce co-education in the college is 0.03. The probability of Mr. Iyengar and Dr. Singh doing the same are respectively 0.05 and 0.8. What is the probability that there will be co-education in college in 2020? And if there is co-education in the college in 2020, what is the probability that Dr. Singh is the assistant professor in the institute? So, if we denote the selection of Mr. Chatterjee by C and selection of Mr. Iyengar by A and selection of Dr. Singh by S, and the chances of getting appointment are in the proportion 4:2:3. So the probability of selection of Mr. Chatterjee in C is equal to 4 divided by 4 plus 2 plus 3, 4 to 6 plus 3, 9. Same way, probability of selection of Mr. Iyengar A is equal to 2 divided by 9, and probability of Dr. Singh S is equal to 3 divided by 9, which can be written as 1 by 3. Now, it has been given the probability that Mr. Chatterjee, if selected, would introduce co-education in the college is 0.03. Means, if Mr. Chatterjee is selected, then the probability of co-education. So, if we consider the event of co-education as E, then probability of E when Chatterjee is selected is equal to 0.3. It is. And probability of co-education when Iyengar is selected, it has been given as 0.5. 0.5 Iyengar के case 0.5. And the probability of co-education if Dr. Singh is selected is equal to 0.8. This is the given data. Now, what is the probability that there will be co-education in the college in 2020? Means we have to find the total probability of co-education. Means the probability of co-education in the case of Mr. Chatterjee plus probability of co-education in the case of Mr. Iyengar and plus probability of co-education in the case of Dr. Singh. So we have to find the total probability. Total probability of co-education is equal to probability of Mr. Chatterjee multiplied by probability of co-education given Mr. Chatterjee is selected plus probability of selection of Mr. Iyengar multiplied by probability of co-education if Mr. Iyengar is selected plus probability of selection of Dr. Singh multiplied by probability of co-education given Dr. Singh is selected. This is equal to probability of C is 4 by 9 multiplied by probability of E when C is given. This is 0.03 means we can write it 3 by 10 plus probability of Iyengar selection 2 by 9. 2 by 9 multiplied by probability of co-education in the case of Iyengar. In the case of Iyengar is 0.5. So 5 by 10 write like this plus probability of selection of Dr. Singh is 1 by 3. 1 by 3 multiplied by probability of co-education in the case of Dr. Singh is 0.8. 8 by 10. This is equal to. This is 3 3 ja 9. We can cancel 2 4 ja 10. 2 2 2 ja 4. 2 5 ja 10. So this is 2 divided by 15. 2 divided by 15 plus this is 5 2 ja 10. 2 2 cancel 1 by 9 plus this is 4 2 ja 8. 5 2 ja 10. So 4 by 15. 4 by 15. Taking LCM, we have LCM is 45. 15 3 ja 45, 2 3 ja 6, plus 9 5 ja 45, it is 5, plus 15 3 ja 45, 4 3 ja 12. This is equal to 6 5 11 plus 12, 23 divided by 45. This is the total probability of co-education. Means the probability that there will be co-education in the college 2020 is 23 by 45. Now, the question is, if there is co-education in the college in 2020, what is the probability that Dr. Singh is the assistant professor in the institute? Means we have to find the probability of Dr. Singh, probability of selection of Dr. Singh if co-education is in 2020. Means if E has been given, this is by Bayes theorem. This is equal to probability of S multiplied by probability of E when S is given divided by the total probability of co-education. This is equal to probability of S multiplied by probability of E when S is given. This is equal to this, means this 4 by 15. 4 by 15 divided by 23 by 45. This is equal to 4 by 15 multiplied by 45 divided by 23. 15 3 ja 45. This is equal to 12 by 23. And this is the right answer. Okay. Now, the next question is the chances that Dr. A will diagnose a disease X correctly is 60%. The chances that a patient will die by his treatment after correct diagnosis is 40%. And the chances of death by wrong diagnosis is 70%. A patient of Dr. A who has the disease X died. What is the probability that his disease was diagnosed correctly? So if we consider C as the event of diagnosis correctly, and W as the event of diagnosis wrongly. यह हमने सपोज कर लिया, ठीक है. chances that Dr. A will diagnose a disease X correctly is 60%. Correctly diagnose करेगा उसका चांस 60%. And the chances that a patient will die by his treatment after correct diagnosis is 40%. And the chances of death by wrong diagnosis is 70%. चलिए, तो इसका मतलब यह है then probability of correct diagnosis, it has been given 60%. 60% means 0.60. Then what is the probability of wrong diagnosis? This is 1 minus probability of correct diagnosis, means 1 minus 0.6. This is equal to 0.4. ठीक है. Now the chances that a patient will die by his treatment after correct diagnosis is 40%. Means if the correct diagnosis is done, then the chances of death is 40%. So if we consider the event D for death, probability of D when there is correct diagnosis is equal to 40%. Means this is equal to 0.40. And probability of death when there is a wrong diagnosis is 70%. 70% means 0.70. Then we have to find the probability of conditional probability. What is the probability that his disease was diagnosed correctly? A patient of Dr. A who has disease X died. Now the observed outcome is observed event is death, means died. D has been given. D has been observed. What is the probability that his disease was diagnosed correctly? Means we have to find the conditional probability of correct diagnosis when द पेशेंट हैज डाइड। ठीक है। So in this case, we have to take the help of Bayes theorem. Probability of conditional probability of C when D is given is equal to probability of C multiplied by probability of D when C is given divided by probability of C multiplied by probability of D when C is given plus probability of W wrong diagnosis multiplied by probability of death when wrong diagnosis was there. This is equal to probability of C 0.6 multiplied by probability of D when C is given is 0.40 divided by 0.6 into 0.40, first is the same, plus probability of wrong diagnosis is 0.4. 0.4 multiplied by probability of death when wrong diagnosis was there is 0.70. 0.70. This is equal to 0.6 multiplied by 0.4. 6 4 ja 24, 0.24 divided by 0.24 plus this is 7 4 ja 28. So 0.28 is equal to 0.24 divided by 8 4 12 and 2 2 4 1 5. 0.52. This is equal to 24 by 52. This is 6 4 ja 24, 13 4 ja 52, and this is the right answer. Means the probability that his disease was diagnosed correctly when the patient died is 6 by 13. Okay. The next question is, in answering a question on a multiple choice test, a student either knows the answer or he guesses. Let P be the probability that he knows the answer and 1 minus P the probability that he guesses the answer. Assume that a student who guesses a answer will be correct with probability 1 by 5, where 5 is the number of multiple choice alternatives. What is the conditional probability that a student knew the answer to a question given that he answered it correctly? In answering a question on a multiple choice test, a student either knows the answer or he guesses. So let K the event of knowing the answer, and J the event of guessing the answer. Given that probability of K equal to P be the probability that he knows the answer, means this is equal to P, and probability of guessing the answer 1 minus P. Okay. Now assume that a student who guesses answer will be correct with probability 1 by 5. It has been given that probability that conditional probability क्या है? Assume that a student who guesses the answer will be correct. अगर वो guess करता है तो correct होगा. तो probability of correct answer when he guesses the answer दिस इज इक्वल टू 1/5। ठीक है। और इसमें ये नहीं दिया है कि आंसर करेक्ट होगा अगर वो जानता है तो उसका प्रोबेबिलिटी। सो कंडीशनल प्रोबेबिलिटी ऑफ करेक्ट आंसर इफ ही नोज इट, दिस इज बाय डिफॉल्ट 1। अगर वो जानता ही है तब तो करेक्ट होने का चांस 1 है, कंप्लीट 100%। सो दिस इज इक्वल टू 1। वी हैव टू फाइंड द प्रोबेबिलिटी। क्या कहता है, व्हाट इज द कंडीशनल प्रोबेबिलिटी दैट ए स्टूडेंट न्यू द आंसर टू a question given that he answered it correctly। अगर वो आंसर करेक्टली आंसर दिया है, अगर उसने करेक्टली आंसर दिया है तो क्या चांस है कि वो जानता था। मीन्स प्रोबेबिलिटी ऑफ नोइंग द आंसर व्हेन द आंसर इज करेक्ट, वी हैव टू फाइंड दिस प्रोबेबिलिटी। अगर आंसर करेक्ट है तो क्या चांस है कि वो उसको जानता था। ठीक है। कैसे निकालेंगे? दिस इज बाय बेस थ्योरम। प्रोबेबिलिटी ऑफ k when c is given is equal to probability of k multiplied by probability of c when k is given divided by probability of k multiplied by probability of c when k is given plus probability of g guessing the answer multiplied by probability of c when guess is given. This is equal to probability of k knowing the answer is p, तो p multiplied by probability of c when he knows the answer is 1, so 1 multi divided by p into 1 plus probability of guessing the answer is 1 minus p, so 1 minus p multiplied by probability of correct answer when he guessed it, this is 1 by 5, so 1 by 5, this is equal to p divided by p plus 1 minus p divided by 5. This is p divided by taking 5 as LCM here. This is 5p plus 1 minus p. This is equal to 5. Denominator goes above. This becomes 5p divided by, it is here 5p minus p. 4p plus 1. 4p plus 1. So this is the right answer in terms of P. ठीक है, दिस इज द राइट आंसर। ओके, इस तरह से हमने कुछ क्वेश्चंस, इंपॉर्टेंट क्वेश्चंस को सॉल्व किया है। बाकी क्वेश्चंस को भी इसी तरह से सॉल्व किया जा सकता है।